Section 8.1 Polar Coordinates. Polar coordinate system uses distances and direction to specify the location of a point in the xy plane. The point is described with a radius r and angle theta. If r is negative, then the point r, theta with a positive r is graphed and reflected into the origin. Example: plot the point whose polar coordinates are 1, 3 pi over 4. In the plane, we draw a segment with radius 1 and rotate it by 3 pi over 4. Another example: plot the point whose polar coordinates are 3, negative pi over 6. Again, we draw a segment with radius 3 and rotate it by negative pi over 6. Now let's plot negative 1, 3 pi over 4. We plot the segment with radius 1, rotate it by 3 pi over 4, and then reflect it through the origin. Here's a relationship between polar and rectangular coordinates. We know that cosine of theta equals x over r, and if we multiply by r on both sides, we get x equals r cosine of theta. Similarly, we can define y equals r sine theta. We also know that the equation of a circle described by a radius of r is x squared plus y squared equals r squared, which can be used to find r. And given x and y, we can use tangent of theta equals y over x to find theta. Example: find rectangular coordinates for the point that has polar coordinates 4, 2 pi over 3. We know that r equals 4 and theta equals 2 pi over 3. Thus, x equal r cosine theta equals 4 cosine of 2 pi over 3, which equals to negative 2. And y equal r sine theta equals 4 sine of 2 pi over 3, which equals 2 square root of 3. Therefore, we have x, y equal negative 2, 2 square root of 3. Another example: express the equation x squared equals 4y in polar coordinates. Replacing x with r cosine theta and y with r sine theta, we get r cosine theta quantity squared equal 4 times r sine of theta. Simplifying it, we get r squared cosine squared theta equal 4r sine of theta. Dividing both sides by r and cosine squared theta, we obtain this equation. We can separate the fraction as a product of two fractions, which can be simplified to r equal 4 tangent of theta secant of theta. Here's another example to graph r equals 5 secant of theta. Let's rewrite secant as 1 over cosine of theta and multiply both sides by cosine of theta. We know that x equals r cosine theta from an earlier slide. Therefore, x equals 5, which is just a vertical line at x equals 5. Let's graph r equals 2 sine theta. If we multiply both sides by r, we get r squared equals 2r sine of theta. Now we know that x squared plus y squared equals r squared, and by replacing r squared with just x squared plus y squared, and we also know that r sine theta is just y, we obtain this equation. And if we set it equal to 0 and complete the square, we get x squared plus quantity y minus 1 squared equals 1. If you remember, this is just the equation of a circle centered at 0, 1 and radius of 1. These are suggested textbook homework problems and required ALEKS homework for section 8.1.